Very good morning, students. Welcome to IIT and NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9th students so far for today's session. As you all well aware, and you can see on the screen, my subject is physics. We are in class 9th. Today we are going to start a new chapter, chapter number 6, which is the syllabus for test 6, which is on 30th December, gravitation. And today we are entering into the session number 1. So today we are going to discuss about the very important topic. Whenever the word gravitation comes, you all recall that Newton sitting under apple tree. Whenever Newton sat under apple tree, when apple fallen down, he started studying about that, why the apple is falling down. Based on that, he introduced the word gravitation. Even before Newton also, so many people might have sat under apple tree and apple might have fallen down. Some of them might have ate, some of them might have sold, but nobody think about the force. That is Newton becomes the father of physics. The way he thought process makes you a success or gives you a success. So with a simple thought, why apple is coming down, he came to know that there is a power for earth to attract the bodies towards itself. Such force with which all the bodies attracted towards the gravity or towards the earth is called gravitational force. For the first time introduced by Sir Isaac Newton. So welcome Gangadhar and Dulapalli branch, right? So today we are going to know about what is the prehistory of gravitation, which is the syllabus for the upcoming test 6, which is on 30th December, right? So gravitation means we come across Sir Isaac Newton, right? Correct or not? We tell that word only, immediately we can recall that if Newton sitting under apple tree and apple is fallen down, then he started research on that and finally introduced the gravitational force, that is force of earth. Gravitation is nothing but force of earth, right? So in this particular topic, in this particular chapter, in coming few days, few sessions, we are going to discuss about universal law of gravitation. Today we'll discuss. Then acceleration due to gravity, why it is attracting towards earth, how the body is changing its acceleration, and finally the difference between mass and weight, which are related to gravitation only. Weight is specially related to gravitation. So these are the three synopses, three concepts we are going to discuss in coming 3 to 4 sessions in deep. Okay. So first we'll start with the universal law of gravitation. Okay, then first when you see introduction here, you can understand there is an interpreting story that Newton was sitting under an apple tree, then an apple fell on him. He knows from the first law of the motion that, so that means, see, what is the first law of Newton? He only proposed, he states that unless force is applied on a body cannot change its position. That means there is some force is acting on the apple. That is the reason apple is coming and reaching the earth. Correct or not? As per Newton's first law of motion. So he taught from that. So immediately he got that there is some force which is acting on the apple and making the apple to attract towards the earth. Such force is named as the gravitational force or force of gravity. Okay. So what is gravitation? Every body not everybody. Every body in the universe attracts every other body. Right? Every body in the universe attracts every other body with a force called force of gravitation. Right? So the force of attraction between the two bodies, gravitational force is the only attractive force. Right? So such a force is called gravitational force or simply a gravity. Okay? So what is stated is, after observing the gravitational force, Newton come to some conclusion in the form of universal gravitational laws. He proposed one law that every body, so every body in the universe attracts every other body with a force called gravitational force. And such gravitational force depends on some factors. This complete slide explains to you about the gravitational force, and there's some new term derived from that, followed by the units. So, as per the universal law of gravitation proposed by Newton, the law states that every body in the universe attracts every other body with a force which is directly proportional to. So that force is directly proportional to product of their masses. That is, suppose the two bodies are there of mass m1, m2. So you see, one is small capital M and one is small m. We can write capital M and m, or m1, m2 you can write. Big body is taken as mass capital M, a small body is small m. Those two are separated by distance of r. So according to the Newton's gravitational law, the force of attraction between two bodies which are separated by a distance of r directly proportional to product of their masses. If the masses product increases, automatically the force increases, and inversely proportional to square of the distance between them. As the distance between them increases, force decreases. Distance decreases, force increases. That's why we call it as inversely proportional. That is the second statement of the Newton's gravitational law. So by combining them, we can get this equation. So F is proportional. Okay, anyway, he wrote M1 and M1, I wrote M1, M2. No matter. M1, M2 by R square. Right? So I can write F is equal to G. G is taken as constant to remove the proportionality symbol. G M1, M2 by R square is the formula for the gravitational force, universal gravitational force. So you know force is measured in Newton only. But what is the G? G is introduced as proportionality constant. In place of proportionality symbol, to remove that, we use the constant. So the G is a constant value. So you have the G value is, we have the G value 6.67. The value of G is 6.67 into 10 power minus 11 Newton meter square by kg square. How you got it? I'll tell. 6.67 into 10 power minus 11 is the value of the capital G, which is also called as universal gravitational constant. Universal gravitational constant. How you got the C? If you want formula for G, take R this side. It becomes F R square. G is equal to, just moving the rearranging by M1, M2. The formula for G. Right. So what is F? F is Newton. R is radius or distance is meters. R square is meter square. Mass into mass, kg into kg, kg square. So we got Newton meter square by kg square unit for the universal gravitational constant, capital G, which is introduced to replace the proportionality constant. So this entire thing is called law of gravitation or universal law of gravitation, which is applicable for entire universe, any body, any two bodies. When they are separated, there may be any medium between them. There may be air, water, or any other things, or even vacuum. Everywhere in the universe, this law is applicable. That's why it is called universal gravitational law. So according to the Newton's universal gravitational law, the force of gravity between the two bodies separated by distance of r is directly proportional to product of their masses and inversely proportional to square of the distance between them. So from we are comparing that, we'll get F is equal to G m1 m2 by r square, where G is called universal gravitational constant, whose value is 6.67 into 10 power minus 7 Newton meter square by kg square, or 9 centimeter square by gram square in other system. Right? So this is the complete details about the universal gravitational law. So before going for the further, I will show you one video on this gravitation, where you can get some more information about the gravitational law and gravitation force.
If we raise a body above the ground and then release it, the body falls down towards the earth due to the force which must be acting on it. The force acts due to force of attraction between the earth and the body, which is called force of gravity. As per the example, the ball thrown upward will fall downwards due to gravitational pull or force of gravitation. Gravitation causes variation of weight of a body, varies from place to place. This would be well understood by studying gravitational phenomenon. Objectives. At the end of this lesson, you'll be able to define force of gravitation.
First point, what are you?
Define universal law of gravitation.
This is today's topic, what we covered.
Understand the meaning of free fall.
That is later we'll discuss.
Distinguish between weight and mass.
Last topic.
Understand thrust and pressure.
Okay, so these are the topics. What we are going. Last one is not there right now. So first four topics we are going to discuss in the chapter. Already we given the synopsis also, right? Okay, observe carefully.
Understand the Archimedes principle.
That is later. Different topic chapter is there for us. So first we'll start with the force of gravity. What is the gravitational force and all we will explain.
Does anyone have thoughts on the reading from last week?
I'm ordering another round. I get discounts. Anyone want one?
I'll take one.
Too late.
Just this add.
कोलंबस वेंचर कॉलोनीज का फोन है.
Force of gravitation. The gravitational pull.
See.
Everything is pulled downwards towards the earth. The force with which two objects attract each other is called force of gravitation. The force of gravitation acts even if the two objects are not connected to each other. Centripetal force. The force due to which the body moves along the circular path acting towards the center of the earth is called centripetal force. The gravitational force between the sun and the earth keeps the earth in uniform circular motion around the sun. This is the centripetal force which acts between the earth and sun. Universal law of gravitation.
What we learned just now.
Everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Force is directly proportional to the product of their masses. Force is inversely proportional to the square of the distance of separation between the two objects, where G is the universal gravitational constant and the SI unit is Newton. Universal law of gravitation is also known as Newton's law of gravitation.
So that's what we've seen till now.
Unit and value of gravitational
What I
constant.
explained to you already. This tell. Listen carefully.
By arranging the expression for force of gravitation, we have G is equal to
FR
F
square
into R square
by
upon
M1 into M2.
M1 into M2. SI unit is Newton meter square per kilogram square or Newton meter square per kg square. The gravitational constant G is equal to the force of gravitation which exists between the two bodies of unit masses kept at a distance from each other. The value of universal gravitational constant is G is equal
6.67
to
into 10 power
6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Importance of universal law of
What is the
gravitation.
importance? Very
The
important.
force binds the earth. The motion of the moon around the sun
All these are because of the gravity.
and the tides due to the moon and the sun.
So this force
3,
is
4.
any
5 నిమిషాలు
planet also.
దొరుకుతుంది లేదంటే 50 రూపాయలు మీది
Okay, anyway, so we'll continue the next class because whatever we learned so far that is shown in the video, the further freely falling body and will come across later. Okay, so this is a complete picture about the Newton's universal law of gravitation. So every body in the universe attracts every other body with a force of gravity. The force is called gravitational force. When two bodies of masses separated by a distance of r, the force between the two bodies is directly proportional to product of their masses and inversely proportional to square of the separation between them. From that we got the equation F is equal to G into M1 M2 by R square, which is a very, very famous formula of Newton's gravitational law. Right? It is a universal gravitational law. From this, you can get the value of G also. I showed also. So G is the constant actually. The constant G is nothing but G you can write as FR square rearrangement by M1 M2. That is, G is nothing but universal gravitational constant. As I told, constant is a constant value also. 6.67 into 10 power minus 11 Newton meter square by kg square. So this is the complete picture about the universal law of gravitation. So gravitational force is nothing but force of earth on a body. So this is not applicable only on earth. It is also applicable in entire universe. Even all the solar planets are also having their own gravitational force by which they are continue to revolve around the same orbit from some hundreds or billions of years. Okay, so this law is applicable for even for the planetary motion or planets also. The force between the earth and moon, the force between the moon and sun, the force between the moon and earth, or sun and moon, sun and earth, or any other planets, all these are this law is applicable everywhere where there are two bodies of some mass. Right? There this law will comes into play. And this value is the remains constant everywhere and anywhere in the universe. G value, capital G value. Okay. Now there is some more explanation about the G. The total characteristics also explained here. So first scientist to measure the value of G experimentally in 1978 is the Newton, and gold ball were suspended near each other by strong thread. By tying the thread, they suspend like this. So the force between the gold balls was measured by knowing the force, masses of the gold balls between them. The value of G is calculated using Newton's gravitational formula. And finally, we got the value as 6.67 into 10 power minus 11 Newton meter square by kg square. Right? So characteristics. What are the characteristics of capital G? You can see here. Right? So characteristics of capital G. It does not depends on the medium between the bodies. So whatever the medium, suppose two bodies are separated in air or in water or in other material, it does not depends. Its value is remains same irrespective of the medium. The second one, it does not depends on the mass of the bodies. Right? It does not depends on the distance between the bodies. So whatever the mass, whatever the distance between them, whatever the materials they are, whatever the medium, it does not depend. It always remains constant. That is 6.67 10 power minus 9 is the constant value everywhere and anywhere in the universe. Okay. So how to estimate the gravitational force between the different objects? From this formula you can calculate. So we know the formula. Okay. From that, by knowing the other value, see, G is equal to F R square by M1, M2 is there. So from this, by knowing the radius, see, you know the radius of Earth, right? You know the mass of the Earth. So the mass of the Earth is, suppose a body is placed somewhere here. Mass of the Earth is given by 6 into 10 power 24 kg. Radius of the Earth is given by 6.4 into 10 power 6 meters. From these two values, you can substitute and get the value of G. That is, radius of Earth is R. So whenever you know the values of, for example, we take, we know F is equal to M by R square. M1, M2 place, I wrote M. Why? Because M is the mass of the Earth, which is very big, and M is the mass of the body. Suppose you paste one pen here. The mass of the pen is small m, mass of the M is Earth. When you drop the pen is attracted by Earth. By substituting the values here, by substituting the values, you know the mass of the Earth, we know the mass of the body, we know the radius of the Earth. Right? From that, we can get the what is the value of G or what is the force of gravity. So by knowing the constant values, we can measure the value of F or value of G. But you know, value of G is always constant, but force can be calculated by, so force between Earth and the body is given by the formula F is equal to Gmm by R square. So by that you can calculate what is the value of, suppose say G, F is equal to G value we know 6.67 into 10 power minus 11, and mass of the Earth you can write 6 into 10 power 24 kg into mass of the body, say some 10 grams body, small body we kept, and M R square, radius of the Earth is 6.4 into 10 power 6 whole square. So by calculating this, you can get the what is the force of attraction between the a body of mass and Earth. So that is also related to the calculation part of the Newton's universal law of gravitation. What is Newton's universal law of gravitation? Which, so clear? So what we learned so far? First, so many of you are joining late. Please come in time, join in time to the class. See, first we started with the what is gravitation. There are three synopses are there. One more. Today we'll complete the first one. Then we move to the second, third in next classes. So what first synopsis is about? Universal law of gravitation. Before that, you should know the introduction of gravitation. So what is the introduction? Everybody know. When a Newton sat under apple tree. Newton sat under apple tree. When apple fallen down, generally what we'll do? We'll eat it, but he not ate it. He observed why it is falling down from the tree. Means there should be some force which is attracting the body towards itself. That is identified as a force of Earth. That is named as gravitational force, or simply a gravity. Right? So gravitational force is nothing but force of Earth, with which Earth is attracts every body towards itself, towards it. Okay, that is called gravitation or gravity. Clear, everyone? Means any two bodies of any masses, when they are separated, there should be a force acting between them. The force acting between them, or between every body separated by some distance, is called gravitational force or force of gravity. So this force depends on some factors, or this force is influenced by some factors. What are the factors? One is mass, second one is distance. So to study the factors, to combine the factors, so Newton proposed a very famous law in gravitation. He already had so many laws are there. Newton's laws of motion. We know 3 laws. Apart from that, another important law in gravitation is Newton's law of gravitation, which is also called universal law of gravitation, because this law is applicable anywhere and everywhere in the universe. So according to this law, when the two bodies of masses m1, m2 are separated by a distance of r, the force between them, the gravitational force between them, is directly proportional to product of their masses and inversely proportional to square of the distance between them. From that we can write F is proportional to m1 m2 by r square. To remove the proportionality, use the constant capital G, which is called universal gravitational constant. So formula is F is equal to G into m1 m2 by r square, where G is called universal gravitational constant, which is having the value of 6.67 into 10 power minus 11 Newton meter square by kg square. Right. So this G value is constant everywhere and anywhere in the universe. It does not depend on the medium between the two bodies. It does not depend on the mass of the bodies. It does not depend on the distance between the bodies. Right. It is always constant, whatever the bodies, whatever the masses, whatever the distance, whatever the medium. Okay. Then when you see the determination of gravitational force, by knowing the mass of the, suppose when you place the certain body of mass away from the earth crust, so the mass of the body and mass of the earth, we know radius of the earth already constant value. By substituting that, we can get the value of, we can estimate the gravitational force between the different bodies. That can be calculated like this. So you can get the force is 9.8 Newton. If you substitute all the values, we know the capital G value, we know the m value and small m value and radius. By substituting that, we got the force is 9.8 Newton. Means when 1 kg of the body is separated from earth, then the force acting on that 1 kg body is 9.8 Newton. 9.8 Newton, right? Then some more topic is there in synopsis 1. So gravitational force between the sun and earth. So, you know, earth revolves around the sun. Then definitely the gravitational force acts between the sun and earth. Okay, the values, if you know, you can calculate. How much force? Same formula is same. Formula is same. But you have to substitute the mass of the sun, mass of the sea. You can write F is equal to G into mass of the earth, mass of the sun by radius of the sun. So substitute. See here. So mass of G value, we know constant value 6.67 into 10 power minus 11. And mass of the earth, we know 16 10 power 24 kg. Mass of the sun is more than the earth, 2 into 10 power 30 kg by radius between sun and earth. Suppose say third orbit we are. Here earth is there. This is sun. This is called radius. The distance from sun to the earth is considered as a radius. Okay. So that is given by 1.5 10 power 29 something is there. Substitute all the values. We'll get the value as what is the force of attraction between the sun and earth value. All substituting the values. Okay. To do the calculations, because the average between sun and earth is very large. It's very large. That is 3.6 into 10 power 22 Newton. See, between earth and the body, it's only 9.8 Newton. But see here, between sun and earth, it is very large force of 3.6 into 10 power 23 newtons force acts between the sun and earth. Tremendous amount of energy force. Okay. So that is can be observed by substituting all the constant values. So this large gravitational force keeps the moon to revolve around the earth. So the gravitational force between two small bodies is very less. The gravitational force between the small bodies and large body, one small and large, is large. The gravitational force between the two large bodies is very large. So depends on the size of the bodies, right? The gravitational force F increases. If both are small, the force is small. If one is big, one is small, like Earth and pen, that's large, little large, 9.8 Newton. If both are large bodies, it is around C, 3.6 into 10 power 22 Newtons. Heavy force. So the total force of gravity depends on the mass and the distance. Whereas gravitation, universal gravitational constant is remains same. It does not depends on the mass of the body. It does not depends on the distance between the bodies. It does not depends on the medium also. So this is a complete picture about the gravitation and universal gravitational law and the value gravitational law between the earth and the body, gravitational law between the moon and the earth, gravitational force between the sun and the earth. Everything is given. By knowing their constant values of radius and mass of the bodies, you can calculate the force acting. See, between earth and between moon and earth, it is 3 point, how much given? See, 2.05 into 10 power 28 Newton. Between sun and earth, it is 3.6 into 10 power 22 Newton. Between earth and the body is only 9.8 Newton. As the size are increasing, automatically the F value increases. Right? So this is the total synopsis one part where we discussed about the what is gravitation, what is the gravitational force, and what are the factors influencing the gravitational force, and which gives the Newton's universal gravitational law. And find that we got the gravitational constant value, which is the constant throughout the universe. So coming days more to discuss about the gravitational force and the gravity. Then one more new word will come, acceleration due to gravity, and you are discussing about the factors of that. So in next coming 2 to 3 classes, we are going to cover the remaining part of the gravitation chapter with complete details and with complete videos also I'll show you. But for today, that's all. You can see the home task. State and explain universal law of gravitation. State means statement you have to give. According to universal law of gravitation, the force between the two bodies are directly proportional to product of their masses and inversely proportional to square of the distance between them. That is a statement. So when come to the explanation, so F is proportional to M1, M2, equation number 1. F is proportional to 1 by R square. Combining 1 and 2, F is proportional to M1, M2 by R square, or F is equal to capital G into M1, M2 by R square, where capital G is called universal gravitational constant, whose value is 6.67 into 10 power minus 11 Newton meter square by kg square. Okay, so this is the explanation part for the universal law of gravitation. Right? So that's all for today. Have a wonderful day. Thank you. So thank you each and everyone. Thank you all KTS, Dulapalli, and Badangpet, Gudimalkapur, Ramagiri High School. Thank you all of you. Have a wonderful day.